So good afternoon again. So in last session we have seen different tests used for determining the shear strength of soil at the laboratory. So for different soil we follow different kind of testing methods. So we have seen direct shear test for cohesion-less soil especially, and then we have UCS test which is used for purely cohesive stiff clays, and then we had vein shear test which we used for soft clayey soils, and we have we seen any other test yesterday? So we have even seen a field vein shear test. So the same testing procedure we can even conduct at the field to determine the shear strength of soft clays at the field itself. So by measuring the torque, you can compute the shear strength. So in today's session, we will discuss triaxial test, which is used for determining the shear strength of soil. And compared to all other tests, this test is the most sophisticated test because you can go for different measurements and it is suitable for all kind of soil and at different drainage conditions. Whereas in the previous test, in case of UCS test, drainage is not possible. And even in case of a direct shear test also, you cannot control the drainage. Whereas in case of triaxial test, you can control drainage. So that's the major advantage of triaxial test. And how could we conduct the test? So as usual, we will be preparing a soil sample which has an L by D ratio of. So what's the common L by D ratio which we maintain? So L by D ratio of 2 is being maintained. What does it mean? So length of the soil will be twice that of the diameter. So generally this dia will be somewhere around 38 mm. So if it is somewhere around 38 mm, then the sample 38 mm or 36 mm, then your sample length will be 75 to 78 mm. So L by D ratio is maintained as 2. What happens if you do not maintain the L by D ratio of 2? Then your failure plane will not exist within the sample. So failure plane sample ki paigano ekkado cut aidi. So as to get the failure plane within the sample, we maintain this L by D ratio generally. Okay. The same dimension of sample as we have used in our UCS test. So same kind of soil sample is prepared for triaxial test also. Whereas there, the sample is not confined with anything. So sample is simply kept on its own self weight. Kada? So one unconfined sample is kept. Whereas here, the sample is covered with the help of rubber membrane. So could you see here in my screen? So rubber membrane is used so as to cover up the sample, and at the top and at the bottom porous stones are being provided, and to hold this membrane with the sample, O-rings are being used. So first sample is taken. So at the top and bottom porous stones are kept, and then you will be inserting the sample into the rubber membrane and then hold it or fasten it with the help of O-ring. So O-ring is a black color ring made of rubber, and it is being inserted at the top and bottom of the sample so as to hold it within the membrane. So once the assembly is done, fix it to this pedestal. So to the pedestal, the sample and along with the porous stones are kept. Okay. So ఇలా దేంట్లో ప్లేస్ చేయాలంటే you have to place this pedestal or you have to keep this one inside your triaxial cell. So what is a triaxial cell? It is a cylindrical cell made of perpex glass. So you can actually see your sample through this glass. So you can visually see what's happening, how your sample is bulging or how your sample is failing. That one you can monitor actually. So this sample setup is kept inside the perpex glass cell, and at the top this cap is being provided, and once the setup is ready, it is connected to the inlet, and through the inlet water is filled up inside the triaxial cell. Okay, so once the water is filled inside the cell, everywhere a pressure will act all around your soil sample. Okay, so throughout all around the soil sample, a cell pressure will exist because all the water will exert some pressure on the sample. Okay, so throughout. So could you understand? So ఒక triaxial cell ఉంటది, మధ్యలో soil sample ఉంటది, పైకి కింద porous stones పెట్టారు, and this cell is totally filled up with water so as to facilitate drainage condition. And at the top you can see a dial gauge for measuring any deformation in the sample. Okay, and at the center you can see a ball bearing is provided. So through this ball bearing, load is actually being applied. Whenever you apply load, you need to measure how much amount of load is being applied. So for measuring the load, we use proving ring, and for measuring deformation, dial gauge is used. So whatever I explained is given here in words. So it's a most versatile test so that it can be applied for all type of soil. Here you can measure pore water measurement because these inlet pipes and outlet pipes are connected to the pressure gauges. So through those pressure gauges you can actually compute the pore water pressure and also how much amount of deviator stress is being applied. And I told you, right, the test is carried out on a cylindrical specimen which has an L by D ratio of 2 and usual size of the sample is 36 mm into 38 mm. So you might have conducted UCS test during your laboratory session. Same size of sample will be prepared for triaxial test also, right? So once the specimen is ready and if you have established the setup, then how will you measure engineering properties of soil? How could you measure CN5 parameters? So and how the test has to be carried out? Listen, once this is the sample, okay? So once the sample is placed here and if the water is let in, it exerts the pressure all around the sample. So that pressure is called cell pressure. And this cell pressure is uniform all around the sample. So horizontally also it is sigma C and vertically also it is sigma C. So don't look at other numbers, just follow my words. So everywhere the sample will exert a pressure of sigma C. Once you fill up your triaxial cell with water. Okay. So now all around the sample is exerting the same amount of pressure or experiencing the same amount of pressure which is equivalent to the cell pressure. Now this simulates the actual field condition. So ground on the so underneath the ground surface, if you consider a soil element, this kind of pressure will be acting throughout. But once the building is being constructed, an additional load will be acting on the vertical direction, right? So that will be simulated by the deviator stress. So your deviator stress or axial stress is denoted by the letter sigma A. 1 minute. Okay, ma'am. So let us see now. I'm sorry, they are asking about your cognizant placement data. See, once the superstructure is being constructed, additional axial stress will act on the soil element. Same way to simulate this in triaxial test, deviator stress is applied through the soil sample. Pressure is applied in the vertical direction in your loading frame. So that stress is called axial stress. So axial stress and note chestaru, in some places it is being denoted by the letter sigma D. So if you wish to know or if you wish to translate them in terms of principal stresses, actually this sigma C is nothing but your sigma 3. So confining pressure antaru, cell pressure antaru, sigma 3 are your minor principal stress. So sigma 3 is the initial stress acting on the soil. And then once the deviator stress is applied, so what is this deviator stress is? This deviator stress is equivalent to sigma 1 minus sigma 3. Okay. So actually what is acting on your soil sample now? So first sigma 3 is acting everywhere as sigma cell pressure act avutundi kada. So this is your sigma 3. Right, and along with this sigma 3, now you have additionally added plus deviator stress చేశారు కదా sigma D act అవుతుంది. So which is nothing but sigma 1 minus sigma 3. So this is applied in the vertical direction. అప్పుడు bottom లో నుంచి కూడా compress అయ్యింది sample. So plus sigma 1 minus sigma 3. Now what happened? This plus already here sigma 3 is acting. Whatever you have applied is sigma D, which is deviator stress, which is equivalent to sigma 1 minus sigma 3. Kada appudu final ga em act iddi mi sample meeda. What is the stress acting actually? Here sigma 3 in the horizontal direction or on the vertical plane, sigma 3 is acting. So ikkada plus sigma 3 undi, ikkada minus sigma 3 undi. So both will get cancelled and you will get sigma 1 acting on your major principal plane. Okay, so you plus sigma 3 minus sigma 3 cancel it. Okay, so actually what you are applying, sigma C confining pressure is applied and then deviator stress is applied. So deviator stress is equivalent to sigma 1 minus sigma 3. Okay, so then finally you will get this kind of stress condition. So once this stress condition is achieved, then what happens? So this stress condition generates zero shear stress on the major and minor principal plane. So this is vertical direction is your minor principal plane direction, whereas the horizontal one is the major principal plane direction. In the context, sigma 1 is the major principal stress. So horizontal direction is the major principal plane's direction. So tau will be equal to 0 in the principal plane's direction once this condition is being achieved. So principal plane lone tau 0 untadi. Whereas if you consider any plane, then there will be a normal stress sigma and a shear stress tau will be there. Okay, so this is how your loading is done in triaxial test. Let's see them in words. So testing procedure. The cylindrical specimen is placed on the porous disc of the triaxial cell above the pedestal and the specimen is encased in the rubber ring as I told you. Then what did we do? So the entire triaxial cell is filled up with water and that water will exert a pressure which is cell pressure or confining pressure radially all around your soil sample. Okay. So once the pressure is being established, okay. So pressure ella established chestamante there will be an inlet. So let me get back to the figure. So here an inlet valve is there, right? So once you open this valve, then water is allowed to let in. So already you have filled up this cell with water. So once further water is applied inside, then what happens? Pressure will be created, no? some pore pressure will be created. So your soil will be experiencing some amount of cell pressure or confining stress. Okay. So once the cell pressure is achieved up to your desired level, so suppose if you wish to simulate a cell pressure or a confining pressure of 100 kPa, which was there at the field condition also, then just increase it up to that pressure. You will be having a pressure gauge. So pressure gauge lo chuste meeku reading telustadi. Once you have achieved that one, keep it constant, then close the valve. Then an additional axial stress is applied. So this additional axial stress sigma A or sigma D is known as deviator stress. And how long you need to increase this axial pressure? So you have to increase it till your specimen cracks or fails. So first sigma 3 all around apply cheyali. దాని తర్వాత sigma 1 minus sigma 3 apply cheyali. So sigma 1 minus sigma 3 ఎంత వరకు apply cheyali? మీ sample crack అయ్యే వరకు apply cheyali. That's it. So this produces, I told you, right, there will be a shear stress on all the planes of the soil sample except this vertical plane and in the horizontal plane. So except this plane and all other planes there will be a shear stress. So మీరు ఏ direction లో తీసుకున్నాను there will be a shear stress except this vertical and horizontal direction, right? So on the horizontal plane and a vertical direction, what is the total axial stress acting? Sigma C and sigma A, right? Sigma C and sigma A acts normal to the plane and that becomes the major principal stress. So what is sigma C? Sigma C is your sigma 3 confining pressure and sigma A anedi sigma 1 minus sigma 3. So ఇది cancel agi. In your horizontal plane, sigma 1 will be acting. Okay. And on the vertical plane, only sigma C is acting. So vertical plane chusarante only sigma C maatrame act ayindi, which is your sigma 3. Okay. Here sigma 1 is acting. So at failure, so your pressure gauges will give you readings, right? So from the gauge you can get the values. So sigma 1, how much is the final sigma 1 applied final major principal stress you can take, which is equal to sigma C plus sigma A, and minor principal stress at failure is equal to sigma 3 F is equal to sigma C. And what is the intermediate principal stress? So intermediate principal stress is sigma 3 is equal to sigma A. Why in the sense? See, you have taken a cylindrical sample, kada? So cylinder anetappudu it's circular in cross section, right? So in such kind of cross section, if I take sigma 3 acting on these two direction, what is sigma 2 also? That will be perpendicular to your plane of paper or plane of your mobile phone, right? So that one is also sigma 3 because of symmetry of your soil sample. Okay. So what are the things that you need to measure while performing triaxial test? You have to measure axial strain. So for the given strain, how much amount of load is being displayed on the proving ring, you have to make a note of. And also you need to measure pore water pressure under no flow condition. So when there is no drainage, how much is the pore water pressure building up? That one also you have to measure. So pore water pressure is U and axial strain epsilon also you have to measure, and change in volume of the sample. So once the soil is confined in the lateral direction, how much ever the deformation is happening is only because of compression of the soil sample. So appudu compression enta undani telistene volume enta change avutundani predict cheyochu. Okay. And during triaxial test, pore pressure measurement will be made under undrained condition. ఎందుకు undrained అప్పుడే pore pressure measure చేస్తారు? If drainage is provided, how pore pressure will build up? All the water whichever is coming in will go off. Then you cannot measure pore pressure. Okay. So once you wish to measure the pore water pressure, then you have to maintain the outlet closed. So undrained condition lane manam pore pressure measure cheyochu. Suppose if you wish to measure the volume change, then you have to switch over to the drained condition. Why? Once the water escapes out, then only the soil will take the load. Okay, so as long as the water is in, the soil will not get stressed. Your total stress will not be shared by the soil particles. So once you allow the water to flow off, where dare ledu, soil compress avvali kada. So once the water is allowed to flow off, then the soil will get compressed and there will be some volume change. So water outlet unte maatrame manam volume change measure cheyagalamu. Whereas if you wish to measure the pore water pressure building up, then you have to close the drainage valve. And what are the stages during triaxial test? In the very beginning, I told you that triaxial test can be conducted in different drainage conditions. So why are we performing the test in different drainage conditions? Why in the sense, when the drainage condition varies, then the strength of the soil measured will also vary. Shear strength, whatever we are computing, will also vary. So water బయటికి వెళ్ళని వదిలితే ఒక C5 వాల్యూస్ వస్తుంది. సో వాటర్ని అరెస్ట్ చేస్తే మీకు ఒక C5 వాల్యూస్ వస్తుంది. సో యూ దెన్ విచ్ వాల్యూ షుడ్ ఐ అడాప్ట్? ఫీల్డ్ లో ఎలా జరుగుతుంది? సో ఫీల్డ్ లో ఈస్ దేర్ ఎనీ ఫీజిబిలిటీ ఆఫ్ డ్రైనేజ్ ఆర్ ఎల్స్ దర్ ఇస్ నో డ్రైనేజ్? దాన్ని బేస్ చేసుకొని మనం suitable test choose చేసుకొని కండక్ట్ చేయాలి. And while performing triaxial test also, we have different drainage conditions. And also this test is being performed in stages. So first you will be preparing the soil sample and then apply the pore water pressure. So sigma 3 is applied and then with that load application, the sample is left as such. Appudu em the sample? It will start consolidating under the given applied load. So just sample తీసుకోవాలి, దాని మీద sigma 3 confining stress apply చేయాలి, leave it as such, then the sample will consolidate. So that is consolidation condition under the given applied load. Later on, you have to allow the water to flow off while conducting the test. So that is drained condition. Okay, so first apply the load and allow the soil to consolidate. Then allow the water to flow off and measure the volume change. So that is the second stage. So that is being mentioned here. The first one is consolidation stage. So what do you do in consolidation stage? The specimen is subjected to a confining pressure on all around the sample and this stage is known as consolidation stage. So after this stage, you will be going for the shearing stage, where drainage is actually allowed. So sigma 1 minus sigma 3 undi kada, deviator stress, that is applied during shearing stage. So additional axial stress is applied on the top of the specimen during shearing stage. And based on the drainage condition, you have different types of triaxial test. So this table will help you to know those types of tests. So first one is unconsolidated undrained test. So before applying the cell pressure, so during consolidation, drainage is not allowed. So the sample is kept as such. So unconsolidated undrained test. So after applying the cell pressure, the soil, the drainage is not allowed. So during consolidation, water has to be expelled out. Whereas here you are not providing any drainage. Appudu soil consolidate avvadu kada. So before applying cell pressure, the sample drainage is not allowed. So that forms an unconsolidated condition. And during shearing also, the water is not allowed to go off. So your outlet valve is totally closed throughout your test. So cell pressure apply cheyanganu sare, malli load deviator stress apply చేసేటప్పుడు కూడా drainage valve close లోనే ఉంటది. So that is unconsolidated undrained test. So in this condition, you can perform the test very quickly. Okay, so the test is being performed in a very quicker time, and this test is also known as QU test, and it requires only 10 to 15 minutes to perform such a test. And what is the next type of test? So in next type of test is consolidated test. So after application of cell pressure, drainage is allowed. So when the drainage is allowed, water will get expelled out of the sample. So consolidation happens. So to such a consolidated sample, during testing, drainage is not allowed. So axial stress apply చేసేటప్పుడు drainage allow చేయరు. అప్పుడు valve close చేసేస్తారు. So that simulates consolidated undrained condition. Okay. See, undrained unconsolidated test ఎప్పుడు perform చేస్తాం? Your building is being constructed in a place where the strata is a clayey strata. Okay. And soon after the construction of the building, if you wish to go for a stability check, so will that building will stay stable or what? Will there be any settlement, or will the shear strength of the soil is sufficient or what? So during that point, your building is newly constructed. అప్పుడు ఆ సాయిల్ మీద దీని ముందు ఎప్పుడు లోడ్ లేదు, ఇప్పుడే ఫస్ట్ టైం లోడ్ అప్లై అవుతుంది, అండ్ యు ఆర్ నాట్ గివింగ్ ఎనీ టైం. సో బిల్డింగ్ కన్స్ట్రక్ట్ చేసిన వెంటనే అది విత్ స్టాండ్ అవుతుందా లేదా అని నాకు తెలుసుకోవాలి. So the condition is unconsolidation condition. So building is just constructed. So you haven't given any time for consolidation to happen. And since the building is constructed, drainage might have got arrested. So it is totally undrained condition. So in order to study the strength parameters of soil soon after construction of a structure, then you go for UU test, unconsolidated undrained test. So after construction, for example, if you are constructing an embankment, after constructing an embankment, but drainage is not provided. So embankment construct చేసేటప్పుడే కాంపాక్ట్ చేసి కన్సాలిడేట్ చేసి దాని తర్వాతనే ఎంబాంక్మెంట్ ఎస్టాబ్లిష్ అయ్యి ఉండొచ్చు, బట్ you are not providing drainage in the later stages. So appudu em cheyalante consolidated undrained test perform cheyali, and this test is otherwise known as QC test antaru, and it takes a duration of 24 to 26 hours. And the last one is consolidated drained test. Actually this test is a very slow test, and it takes sometimes weeks together to get completed. So why? In the sense, if you take a clayey sample, it will be having a very low permeability, and if once you apply the cell pressure and then allow the drainage to flow off, then what happens? Because of low permeability, consolidation will be progressing in a slower fashion. So it may even take 1 week or 2 weeks to get completed. దాని తర్వాత even after applying the deviator stress also, drainage has to take place through the soil sample. అప్పుడు దానికి మళ్ళీ టైం తీసుకుంటది. That is why consolidated drained test is a very slow test, and this test is performed in order to study long term stability of any structure. సో ఒక బిల్డింగ్ కన్స్ట్రక్ట్ చేసి చాలా రోజుల తర్వాత అక్కడ స్ట్రెంగ్త్ సఫిషియెంట్ గా ఉంటుందా లేదా అని లాంగ్ టర్మ్ స్టడీ చేసుకోవాలంటే దెన్ యూ హ్యావ్ టు గో ఫర్ consolidated drained test. Okay. So now we'll see a problem in relation to this shear strength calculation. So this was taken from last year GATE. Okay. And it's a direct question, simple direct question. And I hope before solving this problem, yesterday I have given you an equation. Do you remember? Major principal stress from Mohs circle. So can anyone recollect that? What is sigma 1 is equal to? Sigma 1 is equal to sigma 3 tan square alpha plus 2C tan alpha. I told you yesterday class, we will discuss how this equation came from Mohs circle. Okay, so Mohr Coulomb failure envelope. So let's draw the Mohr Coulomb failure envelope. So as to get it even accurately. So see, this is your soil mass, and here sigma 1 is acting, and here sigma 3 is acting. Right. So in this condition, let's draw the Mohs circle. So to draw the Mohs circle, we will be taking normal stress on the x-axis and shear stress on the y-axis. So let's plot sigma 1 and sigma 3. So let this be sigma 1. Sorry, this be sigma 3 because sigma 3 is the lowest value. So let us take this as sigma 3, and since sigma 1 is larger than sigma 3, let us plot it here. Okay. So if you wish to draw a circle between these two principal stresses, so let's measure the diameter. So how much will be the diameter? ఎంత ఉంటుంది? Can anyone tell me out? So can anyone tell me how much is this distance which I have mentioned arrows? How much is this distance? Sigma 1 minus sigma 3, right? If this is sigma 1 and if this is sigma 3, how much is this distance? Sigma 1 minus sigma 3. See, ikkada idi 3. Idi okavela 5 అని తీసుకుంటాం. How much is this length? 5 minus 3 kada? You remember graph sheet. So this is sigma 1 minus sigma 3. So take the center. So its center will be at the point. So how much will be the stress at the center? So stress at the center will be sigma 1 minus sigma 3 divided by 2. So that forms the center of your Mohs circle. So take that center and draw your Mohs circle. So just construct your Mohs circle like this. And then, see, this is your Mohs circle. Now draw your Mohr Coulomb failure envelope. So just draw a tangent to this circle. Okay. And if you take slope of this line, then it will be equal to 5, right? And here you will be having a y-intercept, which is C, right? So this is how we have constructed the Mohs circle yesterday. So now I wish to know how sigma 1 is equal to sigma 3 tan square alpha plus 2c tan alpha. Ivi naku teliyali. So for that sake, what am I going to do is, let us extend this Mohs circle further. So ela extend chestunnanante, just extend this failure envelope further. So with the same inclination. See, here I am not drawing with scale, so it may not be straight. So but actually you have to just extend this failure envelope and then extend your horizontal axis also. Let this be O. Okay, let this point be O, and see, this is the point on the Mohs circle and your failure envelope is drawn over here. So now just draw a line at an inclination of alpha. Okay, and let this point be C and this point be B, Okay, and just draw the radius. So to get this radius, already here B is there. Let this be A and this be D. Okay, na? So now you have constructed a triangle over here. So ikkada what is AC, ma? What is AC? What is AC is equal to? AC is the radius of Mohs circle. So what's the radius of Mohs circle? Sigma 1 minus sigma 3 by 2. Right? So this is the radius of Mohs circle. And now tell me, this is C. Okay. And if this angle is phi, how much is the angle over here? What is phi actually? So phi is the inclination of this line with respect to horizontal. Then how much is the angle over here? Same phi only, no? See, ikkada nenu free hand to draw chesanu kabatti it is showing a break. Actually here also the angle is the same phi only. Okay, so if this is C and if this is phi, okay, so let us take some name for this point also. So shall we take it as A, B, C, D is there. So shall we take it as E? Okay, so now I wish to know how much is OE is. So how to get OE is equal to, shall I take tan phi? So tan phi in triangle OCE, which is a right triangle, tan phi is equal to C by OE. Kada? So what is OE then? OE is equal to C by tan phi. Kada? So what is OE is equal to? C cot phi. So C cot phi is your OE. Kadama? So now this length is C cot phi. Okay. So now actual గా నాకు ఏం కావాలంటే OA length కావాలి. సో OA length కావాలంటే ఇక్కడ నుంచి ఇక్కడ దాకా what is EB? Hello? What is EB equal to? Could you see? EB ఎంతమా? ఇది 0. ఇక్కడ ఒకవేళ 3 అనే నంబర్ ఉంటే what is EB's length?
3 minus 0, 3.
3 కదా. So here it is sigma 3. Here it is 0. అప్పుడు ఇక్కడ ఏమొస్తుంది? Sigma 3 will be there. So this is C cot phi and this is sigma 3 and you already know what is BA is because BA is the radius of Mohs circle which is sigma 1 minus sigma 3 by 2. Okay. So now take the larger triangle over here and this is also a right triangle. Okay. So consider the triangle OCA. So in the triangle OCA, let me take what sin phi is. So what is sin phi is equal to? Hello. What is sin phi is equal to? So this is right triangle. So here it is 90 degree and your theta is over here. So what is your opposite side? AC by
OC.
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 Where is hypotenuse? 90 degree కి opposite లో ఉండేదే కదా hypotenuse అంటారు.
Yes, ma'am.
Then what is hypotenuse in your triangle OCA?
OA is a hypotenuse.
OA is your hypotenuse. So what is AC is equal to? Radius of your Mohs circle, which is sigma 1 minus sigma 3 by 2. Did I give you already this one? Munde ichesanu kada. Sigma 1 minus sigma 3 by 2 is your AC. Now tell me what is OA is equal to. So OA is combination of C cot phi plus
Sigma 3.
sigma 3 plus
sigma 1
sigma
minus
1
sigma 3.
minus sigma 3 by 2. Am I right? So just simplify this one. So if I wish to simplify, then I'll get. So just take this one there and just simplify it. So sigma 1 minus sigma 3 divided by 2 is equal to, multiply it with the sine phi denominator. So sine phi into C cot phi plus, see here sigma 3 is there, here minus sigma 3 by 2 is there. So what does it mean? Idi 1, idi minus half. So what will you get? Sigma 1 plus sigma 3 by 2 vastada. Am I right? Hello? Ma idi sigma 3 ma, idi minus sigma 3 by 2. Kada? Appudu idi 1, idi minus half. So 1 minus half is half. So sigma 3 by 2. So sigma 1 plus sigma 3 divided by 2 I got. Okay. So our aim is to know what is sigma 1 is equal to. So to get that one, just group the terms. So take sigma 1 terms on one side and sigma 2 and this 2c terms on the other side. Okay. So sigma 1, here one sigma 1 by 2 is there. So let me take this one first. So first it sigma 1 minus sigma 3 pettukuntano. This 2 sine phi, let me write, and then see, this is cot phi, right? So cot phi plus, so here this 2 will be there. So if I bring this 2 over here, sigma 1 plus sigma 3 divided by 2. Okay. So now sigma 1 minus sigma 3 is equal to, see this is 2. What is cot phi is equal to? Cos phi by sin phi kada. So tan theta ante sin by cos. Cot theta ante cos by sin kada. So here sin is there. Here in the denominator sin will be there. So C cos phi will be remaining. If I bring this one inside. So 2 kuda lopaliki తీసుకెళ్ళిపోతామా? So 2 sin phi, ఇది cos phi by sin phi. So sin cancel అయింది. So you got cos phi. Plus this 2 and this 2 will get cancelled and you will get sigma 1 plus sigma 3 into sin phi will be there. Right? Now let us proceed further. So sigma 1 matram group cheyamani cheppan. So sigma 1 here minus sigma 1 sin phi is there. What's remaining over here? 2c cos phi is there plus sigma 3 terms are there, no? So sigma 3 sin phi minus, sorry, plus sigma 3 will be there. So could you understand up to here? So here sigma 1 is there. So from right hand side I brought this minus sigma 1 sin phi, 2c cos phi is there. So here sigma 1 sin phi is there, then sigma 3 came from the left hand side. So now we have grouped it. So now take sigma 1 commonly outside. So 1 minus sin phi is equal to 2c cos phi plus sigma 3 1 plus sin phi is there. So could you guys agree with me? Just sigma 3 sigma 1 ni బయట తీసాను అంతే. So now we need only sigma 1. నాకు ఈ sin phi term వద్దు. Then what am I supposed to do? Sigma 1 is equal to 2c cos phi divided by 1 minus sin phi in plus sigma 3 1 plus sin phi divided by 1 minus sin phi. See here, cos phi divided by 1 minus sin phi is there. 1 plus sin phi divided by 1 minus sin phi is there. See, for these trigonometric terms, if you do simplification so as to get the tan, then this equation will be simplified as sigma 1 is equal to sigma 3 tan square 45 degree plus 5 by 2. You just substitute. See, sin theta anedani 2 cos theta by 2 sin theta by 2 ananta rayachu kada. So just expand them, and then if you simplify it, then you will get tan square 45 degree plus 5 by 2 for 1 plus sin phi divided by 1 minus sin phi, and cos phi divided by 1 minus sin phi can be written as 2c tan 45 degree plus 5 by 2. So you can convert it into this fashion. Okay, because 1 here instead of 1 you can replace it with tan 45 degree, because tan 45 degree is 1, and if you do some simplifications, trigonometric simplification, your equation will assume this form. Okay, so sigma 1 is equal to sigma 3 tan square 45 degree plus 5 by 2 plus 2c tan 45 degree plus 5 by 2. So here, instead of this 45 degree plus 5 by 2, this is actually the plane which gives you the maximum shear stress. So this 45 degree plus 5 by 2 could be replaced by alpha. Okay, so that we will have sigma 1 equal to sigma 3 tan square alpha plus 2c tan alpha. So we will solve the problem in relation to this. See, in a drained triaxial compression test, so could you understand the derivation? So from the Mohs circle and from that graphical representation, just extend the failure envelope till the horizontal axis, and then just solve what is sigma 1 is equal to. Then you will get that equation, sigma 1 is equal to sigma 3 tan square alpha plus 2c tan alpha. Okay. So here a drained triaxial compression test is performed on a sample of sand, and this is from GATE 2020 question paper, a sample of sand, and it fails at a deviator stress of 150 kPa under a confining pressure of 50 kPa. The angle of internal friction of the sample is. So what are they actually asking you? They are asking us to find out what is the value of phi is. So angle of internal friction ఎంత వస్తది అని అడుగుతున్నారు. So here remaining all the data is being given. So actually a triaxial test is conducted on sandy soil. That too it is a drained triaxial test, and they mentioned how much amount of deviator stress is applied at failure, and how much was the confining pressure, everything is being mentioned, and they are asking you how much is the angle of internal friction. And we all know that ultimate aim of conducting triaxial test is to find out the engineering property of soil, which is C and phi. Since it is sand, how much is your C? C is equal to 0. So ikkada oka keyword undi kada sand ani. So your C is equal to 0. So we all know the equation. So sigma 1 is equal to sigma 3 tan square, I'll write like 45 degree plus 5 by 2 plus tan plus 2c tan 45 degree plus 5 by 2. Right? So this is the equation. and they told it's a sand. So C is equal to 0. So what are the other given parameters from the question? Deviator stress they mentioned. So deviator stress ante sigma A or sigma D. So manam sigma D ani teeskuntamu. Sigma D is nothing but sigma 1 minus sigma 3. First cell pressure apply chestaru. Dan tarvata deviator stress apply chestaru. So deviator stress at failure is 150 kPa. Okay, and confining pressure, which is sigma 3. So sigma 3 is equal to 50 kPa. How much is the pore water pressure? Pore water pressure is 0 because it is a drained test. So drained test lopla pore water pressure build up avadu. So pore water pressure is 0. So sigma 3 is known. Sigma 1 minus sigma 3 is given. They are asking you how much is your phi. Since C is equal to 0, ఈ term మొత్తం cancel అయిపోయిద్దా? Okay, so just write your equation like sigma 1 is equal to sigma 3 tan square 45 degree plus 5 by 2. That's it. కదా? So sigma 3 direct గా question లో ఇచ్చేశారు 50 degree. How much is your sigma 1? Sigma 1 ఎంత? Sigma 1 minus sigma 3 is 150 kPa, no? So how much is your
100
sigma
kPa,
1?
ma'am.
Is equal to 150
100
minus
kPa.
50 is your 100 kPa, right? So 100 kPa is your sigma 1. So just substitute sigma 1 is equal to 100 and tan square 45 degree plus 5 by 2. Okay, so which gives you 100 divided by 50 is 2. So you will get tan square 45 degree is equal to 2. So just take a root, then you will get what is tan 45 degree plus 5 by 2. So just take inverse of this. So tan inverse of root 2 entama? Hello. Now you have to use gate calculator and tell me the answer. So with normal calculator it is easy to find. But with gate calculator, just see how to apply and find out tan inverse and all. ఎందుకంటే మీరు ఇక్కడే ఎగ్జామ్ హాల్లో మిస్టేక్ చేస్తారు. సపోజ్ మన ఎగ్జామ్ హాల్లో ఇలా క్యాల్కులేటర్ యూస్ చేసేటప్పుడు మనకు డౌట్స్ వస్తే యూ జస్ట్ ఎంటర్ సమ్ నోన్ వాల్యూస్ అండ్ దెన్ సీ హౌ ద వాల్యూస్ ఆర్ అపియరింగ్ ఆన్ ద క్యాల్సీ. అప్పుడు మనం ఆ పాయింట్ ఆఫ్ టైంలో మనకు మర్చిపోయినా ఇఫ్ యూ ఫర్గెట్ ద ప్రొసీజర్ ఆల్సో దెన్ యూ క్యాన్ ఈజీలీ రెక్టిఫై యువర్ మిస్టేక్. ఓకే, use gate calculator and tell me how much is tan inverse of root 2.
54.73.
Tan inverse of root 2 is
54.735.
so you will get tan 54.735 degrees is equal to tan 45 degree plus 5 by 2. Kada? So now I wish to tan cancel aiti. Tell me how much is your phi. 54.732 minus 45, right? ఇంకా ఏం చేయాలి? You will get an answer into 2. You just take the answer. Ma, how much is sigma 1? This is wrong. How much is sigma 1?
अच्छा 200, ma'am. 200.
अच्छा नहीं है, पूरा गलत है. See, this is 150. This is most common mistake. We should never ever do. It is 200 kPa. Okay, so this is the most common mistake. మన ఏం చేస్తామంటే sigma 1, sigma 3 values చూసినప్పుడే we will be more tempted and we will subtract it. We should not subtract it actually. Okay. So this is wrong. So here the value is 50, whereas this one is 150 plus 50 is actually 200. So now tell me how much is your answer. And never forget to take root also. So root also has to be taken. Are you guys multiplying and finding out the answer? So tan 45 degree plus 5 by 2 is equal to 4 root 2. So root of 4 is 2. Okay. So tan inverse of 2 is 63 degrees. So 45 degree plus 5 by 2 is equal to 63.43. So just subtract minus 45 into 2 will give you somewhere around. How much is your phi now? Phi is equal to 36.86 degrees. Okay, this is your answer. But in the question, what is the decimal places accuracy they are asking you? Round off to nearest integer. So nearest integer and a whole number you have to consider. So what is the nearest integer? Which is equal to 37 degrees. So angle of internal friction of your soil is 37 degrees. So that's your answer. Okay. So are you okay with the problem? Actually here in the question, sigma 1 minus sigma 3 is 150 kPa. What is required? Sigma 1 is required. So it వైపు వెళ్ళేటప్పుడు అది plus అయిపోయింది. So 150 plus 50 is 200. So that was the mistake we did. So rectify it. We'll get this answer. Ma, are you okay with the problem?